Hello everyone. Today I'm very happy to present to you about Smart Inspection of Energy Installation SIEI project submitted to GEX 2021. And in this project particularly we would like to create smart maintenance systems of large power installations like nuclear power plants to small PV arrays and also wind turbines. Now, let's look at SDG 7. SDG 7 is a goal set by United Nations within the framework of Sustainable Development Goals to achieve 100% clean energy by 2030. And if we look at our current progress, and especially in this particular data, we can see that in 2010 we had only 16.4% renewable energy dependency, and then by 2018 we increased to 17.1, which is really less compared to we aim at 100% by 2030. So we need to have some drastic changes, and one of the major things that we need to do is to invest more into renewable energies, change the mindset of the people to move to renewable energies dependencies. We need to constantly innovate new solutions and make the whole energy system more optimized. We need to have very efficient maintenance systems, and by doing all that, reduce the levelized cost of energy or the energy production cost for renewable energy, so that people prefer to invest into that. And in this particular project, we target these 3 points. Now, how we would like to do that? We want to bring in a smart inspection system where we will be deploying drones to inspect all these installations and gather optical and thermal images from drones. These images could be analyzed to see if there are any damages on those power plants and where is this locations, and also estimate the severity of those damages. And based on that, we can automatically create a report or a suggestion systems for the engineers to decide if they should repair it now or later, or how much they should repair. So on this entire scheme, we have this particular area where we need to actually analyze automatically a lots of images, and we prefer to have automated systems because it is less biased, is faster, is less costly. Now, the damages that we are talking about is damages like decoloration, delamination, corrosion, erosion. Something could be broken, there could be cracks, there could be dust, there could be IC failures, and many other categories across different types of power plants. So we started with the top two deep learning architectural pipelines, that is YOLO architecture and efficient dead architecture. They have different versions, so we experimented with almost all of them. And what we can see that if you look at on the top right in this plot, YOLO version 5 is very like the most accurate, but it also has like a lot of flops. Flops is kind of the complexity of the method, of the number of computation that it requires to get the training done. So these experimentational results can help an engineer to decide what level of complexity they require in terms of not sacrificing a lot of the accuracies of the detection. Now, if we look at the data individually, what we can see that if we detect only wind damages or only solar damages, we can maybe use efficient dead in this case, yes. But when we mix all different types of images that we have gathered, the YOLO version 5 performs the best. Now, here is some of the results that we have. So we can see that on the PV panels, when there are some cracks or dust or some other materials covering the surface, it could be detected and necessary actions could be taken. And this is on the wind turbine, and this is on the thermal images of PV panels where we can detect the damaged areas. Now, this concludes our presentation, but what we aim at the end is generate a very efficient system with the maintenance that can help increase the longevity, so the return on investment in these large installations is much higher, and that can help the investors get more inclined toward renewable energy sources and help achieve Sustainable Development Goal 7. Thank you very much.